Now, let's see some formulas connected to line spectrum of hydrogen. Okay. When electrons undergo transition from lower level to higher level, they absorb energy in the form of radiation. When they go from higher level to lower level, they emit energy, whatever is the difference in energy between the two levels, and that is emitted in the form of radiations. So what is the energy, frequency, wave number, etc. of the radiation emitted or absorbed? So first of all, let us see what is the energy of radiation emitted or absorbed. That energy is the difference, I told you, between the two levels. So it is delta E is equal to 2.18. These are all derived formulas, okay? Into 10 raised to minus 18 into 1 by Ni square minus 1 by Nf square. Here, Ni is the initial orbit from where the electronic transition is starting, and Nf is to which level the electronic transition is reaching, okay? Where it is reaching. That is, this is the starting point, this is the final point, okay? So from where the electron is undergoing transition and to which level the transition is done. So accordingly, you will substitute. This is for hydrogen atom and this is expressed in joules. This is for hydrogen atom. Suppose it is not hydrogen atom, what you have to do? You just multiply this by Z square, that's all. Just like in the En formula where Z came as Z square. So same thing you have to do here, okay? So this is delta E. Now if the electron is undergoing transition from lower level to higher level, energy will be absorbed and it will be positive. Okay, the answer will be positive. If it is coming from higher level to lower level, it is emission. Energy is emitted. So that will be negative when you calculate. Okay, because accordingly you'll be substituting it here. Now, the next one is frequency of the radiation emitted or absorbed. You know how energy and frequency are related. You know delta E is equal to h nu. And you know nu is C by lambda. So automatically, if you substitute this delta is equal to h into C by lambda or h into nu, so you can calculate nu as delta E by h. So we can get a derived formula that is nu is equal to 3.29 into 10 raised to 15 into 1 by Ni square minus 1 by Nf square. So this is for hydrogen atom. And the unit will be second inverse or hertz. Anyone you can use. And if it is not, this is for hydrogen atom. If it is not for hydrogen atom, for multi-electronic systems, just multiply it by Z square. That's it. And finally, what about the wave number? I have told you in the same session, nu bar is the wave number and nu bar is 1 by lambda or nu bar is nu by C. You already got nu. So nu by C, you can get the formula for nu bar. So let's see what is the formula. You'll be getting nu bar is equal to 1.09677 into 10 raised to 7 into 1 by Ni square minus 1 by Nf square. As usual, initial and final level. And this is, if it is 10 raised to 7, it will be meter inverse. If it is 10 raised to 5, it will be centimeter inverse. SI unit is meter inverse, so you can go for that. Okay, and this is for hydrogen atom. If it is not hydrogen atom, you can just multiply it by Z square. That's it. Clear? Now, from quantum mechanical model. Quantum mechanical model is about dual nature of particles, dual nature of matter, right? So, matter has both wave nature and particle nature, dual nature of matter. So, de Broglie wavelength of matter waves. Matter has wave nature also. So, what is the wavelength of that matter wave? Here, we get the formula. It is lambda, that is wavelength of the matter wave. That's called de Broglie wavelength is equal to h by mv, where h is the Planck's constant and m is the mass of the particle involved, but it is compulsory that mass should be in kilogram Then this is the velocity of the particle involved. That is supposed to be in meter per second. And then you'll be getting this lambda in meter. You have to be very careful about the unit used in this formula. If they are not in these units, you'll have to convert before you execute those details in the formula. Clear? Then, next one is Heisenberg's uncertainty principle. What is the formula for Heisenberg uncertainty principle? It is delta x into, this is uncertainty in position, delta x, into delta p, this is uncertainty in momentum, is greater than or equal to h by 4 pi, where h is the Planck's constant. And then p, momentum, is mass into velocity. When you substitute that, you'll be getting delta x into delta v is greater than or equal to h by 4 pi m. That is, this will be m into v. So when you take it as delta v, this m will go there. So this is the modified formula. Delta x is the uncertainty in position. Delta v is the uncertainty in velocity. Then h is the Planck's constant. And here, this m should be expressed in kilogram. It is compulsory. Delta x should be expressed in meter. Delta v should be expressed in meter per second. And this mass should be expressed in kilogram. These are compulsory. Clear? So that's all about Heisenberg's uncertainty principle. So these are the formulas. These are important formulas from structure of atom. And I hope all of them are clear. And practice them very well. They'll help you a lot in your competitive examinations as well as class 7 chemistry. So as I always tell you, please like, share and subscribe to my channel. Also, please comment on the videos posted. Thank you. Bye.